differ from men, and we can separate the sexes, and that women were disproportionately affected by Alzheimer's disease because we lived longer, because age played a role in it. But we now have substantial evidence to show that it's not the fact that women live longer or people in general, because dementia and Alzheimer's disease are not part of the natural brain aging process. For women, and they differ from men, and we can separate the sexes and talk about it. For women, it is purely because being a woman is a risk factor for getting this disease. Now, if we go through and we have a look at all of the people that currently have Alzheimer's disease, 95% of them could have been prevented, because this is not a disease of genetics, it's a disease of lifestyle.
95% of it could have been prevented?
Correct. We're born with our genetic makeup, meaning that, for example, if you have a genetic mutation on chromosome 4, you will get Huntington's disease. There is nothing we can do about that. That's how you were born. But when it comes to Alzheimer's disease, there's around 20 to 30 genes involved in the disease. Only around 3% of the disease cases right now were driven through those genetic mutations. The genetic mutations that you are born with, you get them from mum and dad, are presenilin 1, presenilin 2, and the amyloid precursor protein. So if you have a genetic mutation in one of these genes, you will get some form of dementia.
What is the age range where people will start to experience Alzheimer's?
Let's just actually take a broad overview of what Alzheimer's disease is, okay? So you've probably heard of dementia.
Yeah.
So dementia is the umbrella term. So Alzheimer's disease sits under the umbrella. It's a form of dementia. There's frontotemporal dementia, which is what Bruce Willis has. There's dementia with Lewy bodies. There's Parkinson's dementia. There's vascular dementia. This disease, dementia or Alzheimer's disease, is a disease of midlife. And so it generally starts in our 30s. It starts in our 30s, but the first symptoms show up in our late 60s, 70s, and beyond.
When you say it starts?
Yeah. Our brain fully develops at around 25 years old, 25 to 30. And after that, that's when if we don't take care of our brain, we start getting a decline in these functions. Now, let's go back to the brain. The brain is 87 billion neurons, around 5 to 10,000 connections per neuron. My favorite area of the brain is the cerebellum, and the Purkinje cells inside the cerebellum have upwards of 50,000 connections per cell. So tightly dense, and there is so much happening, it takes 20% of the total calories that you consume every day to power this thing. And it's the most vascular-rich organ in the entire body. Over time, through things such as sleep deprivation, poor diet, lack of physical activity, environmental toxins, this slowly erodes at the functioning of the brain. And over time, this starts to compound, because that's what biology is. Everything is compounding. One night of sleep deprivation raises your risk of amyloid beta, which is one of the hallmarks of Alzheimer's disease pathology, by 4%. That's just one night of sleep deprivation. Imagine a new mother or a shift worker or a physician in their residency getting countless nights of sleep deprivation day in and day out. Imagine all of that compounding. And what happens? Well, we end up with either neuronal loss, which is like the complete atrophy of certain parts of the brain. And that's what is mild cognitive impairment. Mild cognitive impairment is a pre-dementia state.
So what is this that I have here, this photo of a brain?
You've got the sagittal view right now of the brain, and we're looking at a healthy brain on here. As you can see, I'm going to show it up here. On the left-hand side, you can see that the brain is thick. We can see that the integrity of the gray matter, which sits out here, is thick. It's voluminous, okay? We can see that the ventricles are smaller. We go over here and we see thinning of the cortex. You can see these big spaces between the gyri. These are thick because the gray matter has atrophied. It's shrunk. You can see that the space between the cortex itself and the skull, there's a bigger space. You can see these ventricles here, these butterfly-shaped ventricles. This is thicker. This is thinner. We can see atrophy down here. So essentially, the brain is getting smaller and smaller.
At the age of 30,
These are thick because the gray matter has atrophied. It's shrunk. You can see that the space between the cortex itself and the skull, there's a bigger space. You can see these ventricles here, these butterfly-shaped ventricles. This is thicker. This is thinner. We can see atrophy down here. So essentially, the brain is getting smaller and smaller.
At the age of 30, if I do everything right, and we were to sort of plot this on a graph of where I land at 70, what is the variance of where I'll end up at 70? You know, my brain is quite important to me. And I do worry. I think, I think I worry in part because I sit and interview a lot of people at a lot of different ages. And one thing you notice as an interviewer is some people at 60 are razor sharp.
Mm-hmm.
And some people at 60 are not as razor sharp.
Yeah.
Their ability to articulate their words, their memory recall, their ability to understand stats and stories, all of this. And I sit here and go, I wonder what the difference is.
Yeah. And that's actually beautiful because it brings up this important concept in neuroscience called cognitive reserve. And that's your brain's ability to withhold capacity to overcome stresses. Okay. So you've probably heard, for example, let's use the analogy of physical performance. Mm-hmm. Your VO2 max, which is a measure of your peak respiratory fitness, you know, how well you can utilize oxygen mm-hmm. when you are at a high intensity state. How well does your body utilize oxygen? The fitter you are, the more reserve you have to overcome stress. Stress such as an infection, everyday stresses, sleep deprivation, surgery. The more reserve you have in your bank to overcome that. The same is with your brain. The more cognitive reserve that you have, the more cognitive capacity that you have been training year on and year out will save you at 60 from harmful insults, such as you can get a woman at the age of 80 with a head full of amyloid beta.
Amyloid beta being?
One of the hallmarks of Alzheimer's disease. You can get somebody with a head full of amyloid.
Which is like a plaque on the brain.
Yeah, it's a protein that's actually, it's a protein that lives inside the neuron itself. And we can explain what that is, which I will in a second. But let me just tell you, you can have a head full of amyloid in this person and they have retained their cognitive functions. Then you can have somebody else with hardly any amyloid, but they've lost their cognitive functions. And this all comes down to cognitive reserve.
And cognitive reserve lives where in the head?
You've got around 5,000 to 10,000 connections per cell. Over time, those connections fail. Now, those connections are responsible for your thinking, your processing speed. Every time you have a thought, you build a new connection. The more connections that you have, the more things that you see, the more novelty that you give your brain, the richer it gets, the more stable it gets. So the ends of the neurons, we have dendrites. And coming off the dendrites are these little trees. Imagine a branch. That's the dendrite, and all of the leaves that come off it, all these little dendritic trees, if you will, and they connect to nearby cells, 10,000 cells. Over time, those are the connections that fall. Those are the connections that fail. They fail because you don't utilize them.
So the way that one would build reserve.
You see, the more novelty that you give your brain, the richer it gets, the more stable it gets. So the ends of the neurons, we have dendrites. And coming off the dendrites are these little trees. Imagine a branch. That's the dendrite. And all of the leaves that come off it, all these little dendritic trees, if you will. And they connect to nearby cells, 10,000 cells. Over time, those are the connections that fall. Those are the connections that fail. They fail because you don't utilize them.
So the way that one would build reserve at the age of 30 is
by exercising. We can build reserve in a number of different ways. In fact, there was a really wonderful study that just came out that I just read about, and they found that those who preserved cognitive capacity at 75 years old were handwriting and reading. So handwriting and reading preserves cognitive functions. Exercise is one of the most potent stimulus for brain health and Alzheimer's disease prevention and cognitive reserve. The more you exercise, the bigger your brain.
What about scrolling on social media? Does it improve my reserve if I'm watching videos
It's in the opposite.
Why would that be? Because I'm still learning stuff
Yeah.
when I'm on the internet.
Because what you're doing then is you are relying on short dopamine hits. Every time you scroll, you're sending signals to your brain that you're getting a dopamine hit. And your brain gets used to it. Remember, your brain is only there for two things: survival and reproduction. So every time that you stress your brain in the smallest amount of times, you're giving it dopamine hits, it doesn't allow us to do other things for a sustained period of time, like focus, read, have a conversation.
So writing and reading are good for building up my neurological reserves.
Yeah, neurological reserves. It doesn't compare to what exercise can do for the brain. And it's so sad because around 80% of the US population don't exercise for at least 30 minutes a week, which is actually quite scary. The physical activity guidelines are 150 minutes to 300 minutes of moderate to rigorous physical activity per week.
What's the most compelling study you've ever encountered that proves that exercise is central to Alzheimer's prevention and brain health?
When we look at all of the data, we can see that the biggest amount of return on investment is from resistance training.
Resistance training being?
Strength training. One of the most compelling studies was probably the SMART trial, where they took a group of people with mild cognitive impairment and gave them 2 to 3 times per week of resistance training. And they not only preserved their cognitive functions, they enhanced their processing speed, they enhanced their fluid intelligence, and they had slowing of the grey matter.
The grey matter?
Yeah. So your brain consists of both grey and white matter. So grey matter are the cell bodies that lives on the outer portions of your brain. And the white matter is deep within the brain. And that's where all of our myelinated neurons live. And over time, we see that we can have little lesions in the white matter of the brain. So a lot of the times, per week of resistance training, and they not only preserved their cognitive functions, they enhanced their processing speed, they enhanced their fluid intelligence, and they had slowing of the grey matter.
The grey matter?
Yeah. So your brain consists of both grey and white matter. So grey matter are the cell bodies that lives on the outer portions of your brain, and the white matter is deep within the brain, and that's where all of our myelinated neurons live. And over time, we see that we can have little lesions in the white matter of the brain. So a lot of the times people will ask me, Stephen, I'm scared. My mother had Alzheimer's disease. I'm scared I'm going to get it. And we were talking about genetics before. And there's another genetic risk factor that we didn't talk about. The ApoE4 gene is one of the strongest risk factors of getting Alzheimer's disease, but it is not a foregone conclusion that you're going to get it. So Chris Hemsworth was tested and he has 2 copies of this gene. So you get 2 copies, one from mum, one from dad. It's the apolipoprotein E gene. And it comes in 3 main variants. So you've got ApoE2, ApoE3, and ApoE4. So I'm a 3-3 carrier. I've been tested. And that's the gene. So ApoE4 gene is one of the strongest risk factors of getting Alzheimer's disease, but it is not a foregone conclusion that you're going to get it. So Chris Hemsworth was tested and he has 2 copies of this gene. So you get 2 copies, one from mum, one from dad. It's the apolipoprotein E gene. And it comes in 3 main variants. So you've got ApoE2, ApoE3, and ApoE4. So I'm a 3-3 carrier. I've been tested. And that's the general population. They're 3-3. So it doesn't raise my risk of getting the disease, but it also doesn't protect me. If you've got a copy of the ApoE2 gene, it protects you against the disease. But when you have a copy of the ApoE4 gene, it raises your risk by 2 to 3 times. If you have 2 copies of the gene, it raises your risk by 10 times if you are a male. Here's the devastating thing. If you are a female with 1 copy of the gene, you are at double the risk than your male counterpart. So 1 copy of the